Hey, good morning, everybody. All right. Today we have a decent amount to get through, but we're going to talk about scatter plots, determining correlation, of course, line of best fit. So, before we get into today's content, I just want to do a mini intro here at the top. It says many of you have seen graphs like this, and they often show up in advertising, research articles, etc., to link two variables together. So, if we look, like you might have seen a graph like this if your parents are looking at the price of a car and what your overall career salary is. So this shows, as you can see, like the higher your salary is, the higher your car price is usually. Like here's a dot at 150,000, a dot at almost 100,000. Okay. Another example that you might have seen is like the average daily temperature compared to the number of visitors that go to the beach, right? So the hotter the day it is, the more the people that go to the beach, right? So what we can say and what we'll look at is that a correlation? So is that actually true? Is it true that, your average daily temperature causes more people to go to the beach, or is it just coincidental, right? So grade point average, your GPA. Okay, how is your GPA compared to the hours of the video games you've played? Now, this is from Math Warehouse, and I don't know how accurate this graph is, but this looks like your GPA goes down compared to the number of hours you spend playing video games. Whether that's true or not, we would have to actually see the actual evidence. But according to this, I mean, it looks like a pretty decent negative correlation. So it looks like the higher it is for the hours of games played, the lower your GPA is, right? So anyways, what you can make about these, the point about all these graphs is there's some type of correlation, right? They're comparing two things. And what we are usually comparing is called the independent variable and the dependent variable, okay? So we have two items that we're like, all right, well, for instance, like the weather and somebody's mood. Like, if it rains outside, does that affect your mood? Well, we can compare those two things, right? And what you have is you have an independent and a dependent variable. Your independent variable is usually your x. It's on your x-axis, and it does not depend on any other value. Like rain doesn't care if you're happy about it or not, right? It's going to do it whether you want it to or not, okay? But the dependent variable, usually the y, is dependent on the x value. And so I want you to think of that as like the output for a given input. So for example, with the rain we just talked about, the rain, does it mean a bad mood? Right? For some people it does. For some people it doesn't. Like I personally kind of like the rain, especially after it's been hot for a couple days. But some people might be like, ugh, it's rainy out. I really don't want to do anything. But again, on the flip side, just because you're in a bad mood doesn't mean it rains, right? So our dependent variable in this situation would be your mood, and our independent variable would be the rain. So rain would be our x value, and our mood would be our y value. The more it rains, the worse the mood gets, right? So that's something to think about there. And so if you look at a graph, you can see independent variable is always labeled on the bottom. You label whatever it is. In this case, it would be rain. And dependent variable is always on the y-axis. Okay, and then if you look, you can see that there are a bunch of dots. These are all the scatter points, so whatever it may be. So like if it's saying days it rained or something, in bad mood, right? So you might say, oh, it rained 2 days out of the year. Oh, their mood is not very bad, right? Like the higher it is, the worse the mood would be. Okay, and then you have things that are called outliers. So an outlier is where you have this statistical anomaly where everything else seems to follow this trend, right? Or seems to follow this trend line, or what we also call line of best fit, okay, that we're going to talk about today, right? But then there's just this one that sticks out, right? Another way to think about that is like test scores. Sometimes, like as teachers, we'll average out the test scores and say, oh, they're all about in here. And then one person either did really well or one person did really bad, right? And so they're not on the trend line, and we would call them the outlier. So in statistics, sometimes when you're looking at these, they'll actually remove those outliers just to see what the average is. They'll take them out. They'll say, well, that's not normal, right? An outlier isn't normal, so they'll take them out. All right. So, and just to confirm, this is a scatter plot. It's got a bunch of points plotted all across. And notice it's called a scatter plot because we don't connect all the dots. We just draw a line that seems to go through the middle of those, right? And so a scatter plot is a set of ordered pairs, both independent and dependent variables, graphed on a coordinate plane. Pretty simple. All right. So why is all this stuff important? Well, as I mentioned, it has to do with correlation. So correlation, and there's a gizmo right here, a link that you can always click. It'll actually help you if this isn't making sense. But correlation is used to describe the strength and direction what do I say? The strength and blank of a relationship. Oh, direction. Between two variables. So what that means is you could have multiple things. You could have it be positive, negative, or no correlation. Okay, so these are all the type that you could have. And then you could also have how strong they are. So you could say that it's very strong, it's moderate, which it means just, it's okay, it doesn't show a whole lot, or it's weak. Okay, and what we say is that weak is between, well, strong is like 0.7 to 1. This is like a 0.4 to 0.69, we'll say. And then this is like 0.1 to 0.39, okay? And now why do those numbers make sense? I guess I should have went over this before, because correlation goes from -1 to 1. So if we want to show that two things correlate together, so like, does the rain correlate with somebody's mood, or do homework scores correlate with test averages? Okay, we look at an R number, this R number that you see here, and that is a correlation coefficient. Okay, so that correlation coefficient is how you determine like the strength of the two things that you're comparing, right? So let me get logged in here to Canvas. Sorry, in the background, I'm gonna do something at the same time here. But what we want to do is just look at these top ones here, and we're just gonna say, what they are. So this first one, it goes all the way up to a +1. That's the highest it can get. Okay, so we call that a very strong positive correlation. Okay, and if it's 1, that means pretty much all of them are exactly on the line. Okay, 0.8, notice a couple of them are kind of on the opposite sides there, but it's still a very strong correlation. This is strong, and the graph is positive. Okay, 0.3, notice that even though this line of best fit is there, it's not necessarily very strong, like the graphs or the dots are kind of off of it, so we would call this a weak positive. Okay, if it's 0, so if there's a 0 in between the 1 and the -1, that means that this has no correlation. Okay, so some of you would argue that video games and grades have no correlation, which isn't true, but I like your effort. Okay, R value of -0.3, so this is negative, this is a weak negative. It means that there could be a negative correlation, but it's pretty weak. It's not, we aren't able to use that as evidence. -0.8 is a strong negative, which means they're definitely related. One thing causes the opposite of the other. And -1 is very strong as well. Strong negative. Okay? All right, so correlation will help determine if there is cause and effect. Does homework completion affect overall grade? How could we test that theory? Well, we could plot homework versus overall grade, right? And then check the correlation coefficient. Okay, remember R is the correlation coefficient. So that's like once you plug that in, it's saying this is how much those things are correlated. So that's where we would say, oh, it's a strong positive correlation or a strong negative. Okay. Let's see here. Next, okay, can you predict the future? Well, with the line of best fit, you can. I know, so you've always wanted to be able to predict the future, right? Well, line of best fit, you can do basically just that, okay? Line of best fit is where you're looking at a scatter plot and you draw a line that best represents the data. It typically goes through the middle of the data, okay? And so you might have like a few points, but in general, where would the points lie? The points lie compared to the line of best fit. Hopefully, they're even on both sides of the line of best fit and on it, okay? So what we mean by that is, as you look at this next example, it says calculate the line of best fit, then apply, draw a line of best fit for the scatter plot. Look at these points here. So we have one here, here, right, going through. So we want to draw a line that tries to have a similar amount on both sides. So for instance, if I go like this and draw my line of best fit, well, look, now I've got 2, 3, 4, 5 dots on the bottom, and I don't have any on top. So that would not be a very good line of best fit. So instead, we want to draw a line that tries to have about the same amount, okay, on both the top and the bottom. So I would argue that that's probably a line of best fit. All right, and then it says, what's nice about this is once you actually have your line of best fit, now this is an estimate, but I will show you a way with Desmos that you can actually do it for real. The nice thing is you can estimate future examples, right? So in this case, it says, without actually finding the equation of your trend line, use the line of best fit to estimate the Olympic high jump record in 1986. Well, you can see that there is nothing here for 1986. Okay, but based on the line that we just drew, okay, 1986 would be right here. It looks like that would be roughly about 93 right here, okay? It looks like it'd be about 93 inches. Would have been the high jump record in 1986, okay? So what we can do is actually use that to try to predict and average out data. All right, so let's continue on. Using the graph below, find the equation of the trend line, answer the following questions. Again, draw a graph. Okay, so I'm going to try as best as possible to draw a line through the majority of the points, okay? In this case, it looks like this. And then that leaves me with 1, 2 on top, 1, 2, 3 on the bottom. That's pretty close. Okay, so now using Desmos, we want to write the equation of the trend line. All right, so here's where it gets interesting. We are actually going to write the line of the trend, okay? So what I need to do in order to do this, we are going to fill out a table. So the first one, let's put 1623. We got to start listing all of our points because we're going to put those in a table. Okay, so I'm going to open up Desmos here, just move it off to the side for a sec. All right, and so the next point looks like it's 1720. Next one looks like it's 1819. Okay, this one is 1915. This one is 2015. This one is 2114. This one is 2214. This one is 2317. And the last one is 24 and 11. Okay, so again, I'm writing down what are my X and Y values because in Desmos now, what we're going to do is we're going to add a table and we're actually going to figure out what this line of best fit is so we can more accurately predict it. It'll do it automatically for us. So in Desmos, click the little plus sign that you see right there above the 1. Okay, and then you're going to add a table. All right, under X1, I want you to go ahead and list out all your X values. So 16, 17, 18, 19, 20, 21, 22, 23, and it actually starts labeling it for you, right, as long as it's in the same order. Okay, so I got all my X values. Now I'm going to start plotting my Y values with those. So 16, 23, 17, 20, 18, 19, 19 was 15, 20 was with 15 as well, 21 with 14, 22 with 14, oops, 23 was 17, and 24, oops, 24 with 11. I don't know why I'm messing up there. Okay, so once you have your table filled out, okay, you're going to adjust your window to include all the data points. All right. So I'm going to hit this, and I'm going to adjust the table. Now, to do that, you want to like switch up this x-axis and y-axis, okay? The other thing that you could do is you could zoom in and zoom out, right? There we go. I don't know that we need it to be 50. Okay, so I'm going to go back to the tool, or the wrench right there, and I'm going to put, I think we can go from -2 to 25, and that should be good. And then y-axis, let's go from 0 to 25. Okay. So that includes all of our points. All right. So now go back to the plus button and add a line here. So down here, okay, and you're gonna add the expression at the top. It says like FX expression up here. Okay, and we are going to add in y equals mx plus b, which you should recognize because that's slope-intercept form. So what we're going to do is we're basically going to draw a line down through those. Okay, and then it says what sliders do you want to add? You want to go ahead and hit the all button. Okay, and then adjust the sliders until you have a line which captures the trend line, splits the data in half. Okay, so basically we want to change this slope and the y-intercept to be 20, 50. There we go. Maybe even 49. Okay, I'm actually going to do this just so I can see it a little better. Okay. So that actually looks pretty good. Maybe do it to like -2. Nope. -1 maybe, or 1.3, and then move this down. Bingo. That looks like it's pretty good. Looks like it goes through that. Okay. So our formula there that we would write down in our notability for the line of best fit would be y equals, and this is usually, line of best fit is not an exact number, so some of yours may be a little bit different than mine, and that's okay, but as long as it's pretty close. So there's our equation. So y equals -1/3 x plus 43. All right. Last two questions here, and then you can get onto your exit ticket. Car rental companies allow people that are 25 years old to rent them from them at a much lower rate. Use your equation to find how many accidents 25-year-olds are in. Okay, so now that we have our equation, we can basically just solve using Desmos again. But we want to plug in that a 25-year-old, and we want to see how many accidents he has. So 25 is the age. That would be the independent variable. That's x. So we're going to plug 25 in for this x value. So y equals -1.3 times the 25-year-old plus 43. Okay, and so when we plug that in, -1.3 times 25 plus 43, they would be in about, I'm using the squigglies to show, about 10.5 accidents per year. Well, it doesn't really say per year. Just 10.5 accidents, I think, over their time period. At what age could you predict that 100 drivers will get in 5 or less accidents? At what age would you predict that 100 drivers will get in 5 or less accidents? So this is per 100 drivers. So what that means is when I go down here to 5, which this is 9, so it's going to be like down here, what age could we predict that to happen? Okay, well, we could plug that in and say 5 because that's our end goal now. And then just try to solve it. So negative 38 equals negative 1.3x. And then divide by negative 1.3 to get x by itself. And this is going to tell us what age that's most likely to happen, that there'll be only 5 accidents at that age. They'll only have 5 accidents registered for this age group, I mean. Oh, and a negative over a negative is a positive, right? So it'd be about 29. 29 years old. Okay, would be 5 total accidents registered. All right, so I showed you how to do it with Desmos. Obviously, you can go back, pause the video, rewatch it if you need to, but everything's here for you. So you're going to go ahead and fill out these 2 answers or these 2 questions on the exit ticket. Let me know if you have any questions. I'll be available periodically throughout the weekend as well. So again, let me know if you have any questions. Good luck, and I'll see you guys in class.